Hello everyone! So today we're going to talk about power electronics. At my side, Ralf Linnertz.
Hi, Chris.
Thank you very much. My name, like you said, is already Chris. I'm responsible for the LN Academy. Okay, Ralf, before we take a closer look to that system over here, so the general topic is here power electronics. What does power electronics mean and where do we find it in our all-day life? So how important is it for us basically?
Okay, in our all-day life, we have many different speed variable drives,
Okay.
especially in industry. So you can't imagine industry without speed variable drives.
Mm-hmm.
So for example, your frequency converters, servo drives for positioning and so on, all those things. Imagine the new cars, electric vehicles, also the same.
So what are the topics, before you go in detail here, what are the topics basically where we're going to look at when we taking care of that training system?
So we split the system in two ways. One way is line commutated converters, where we look for thyristors, diodes, and so on.
Okay.
And then we have the self-commutated converters, which belongs to the IGBT.
Okay, that sounds pretty complex. Who will learn with that system and where will it be used for training basically, or apprenticeship?
So the system is used for many people. So we start on a very low level, for example, vocational training. Then we go to technical colleges, universities, and also in research area we use it together with MATLAB.
Okay, so also here a very broad or wide field of different institutions, people, students who can learn with the system. We see the system is highly flexible, everything is modular set up here. So when we're looking now at the electric drive down here, what about the different power classes and motor types in that system?
As also in other systems for drive technology, we start here with the unit train level, so
Okay.
the basic system. Then the next level we see here is a 300 watt class. And the next class is even like in the machines, the 1 kilowatt class.
We have a high flexibility here from the very basics with the unit train working up really to the university level. So I would say now the stage is yours, that you can give us a deep dive into that system here and explain a little bit more in detail what we see here and what we can do with it. As we know, as typical for Lucas Müller products, we always have an e-learning course coming with the system together, which is called LabSoft, so the software where everything is working in. And on the other hand then, this system works together with this course, and I think you will show us this as well, right?
Correct.
So, have fun and enjoy his presentation.
Let's start. Coming to the heart of the system of the self-commutated converter circuits. This unit here. The unit consists of 6 IGBTs for controlling the load. We have here a brake chopper inside, and the system is driven by a microcontroller, and all the measurements are also included in this unit. So the communication to get the values will be done by the USB bus directly to the PC. So on the right hand side we have the load, which is an ohmic and an inductive part, and this can be freely connected to our converter circuit. On the left hand side we see our power supply. We have here the possibility to work with a reduced voltage and also the possibility to use directly mains voltage. Our converter circuits will handle all voltages, even small and also good voltages. On the lower part here we have our machine test system. When we use the system together with the motor, we use the machine test system to load the motor, the meter here, and so we have a complete system. In the upper rack we have the line commutated converters. As you see, I can interchange this unit with this unit and can use the power supply and also the load as the same to reduce the cost. Let's start with the LabSoft course for self-commutated converters. In this course we are concentrating us for single quadrant converter, 4-quadrant converter, inverter technologies, so make from DC AC, and also 3-phase inverter. I will not go in many details. Let me show you only one example for an experiment. So modern frequency converter works with space vector control. So there's a special technique for controlling the IGBTs. For this purpose, to understand it, how it works, we call it a virtual instrument. Let me open it. This instrument is called space vector control. So I open the space vector control instrument, say power, so the IGBTs get powered, and if I press this auto run button, you see that we now apply a sequence to our frequency converter. With this frequency sequence, also the load gets powered. And this sequence you can imagine with the angle here will turn the motor. So at the moment we have 6 stages which are turning the motor. So the motor will make click, click, click. But now we try the next step to make it more smooth. And we go to the linear, and now the system behaves like a linear. Here in this case we have the problem that the resulting vector is getting smaller and bigger. Also this causes interference into the motor, and the motor will not run smoothly. So the last step is that we say here to sign, and now we can rotate our vector on the circle, and so the motor can run very smoothly. That's the principle. Even almost all new systems work. Even in automotive, the car will use this principle. In the industry, the frequency in the servo converter will use this technology, and here in the course we will show this. So now you see that the system is working with our load, but it would be more interesting if we use the motor to turn it. So let me demonstrate you how this works too. So I will stop working here. Okay, now I will remove the load and connect the motor to our converter circuit. Now let's connect the motor to our frequency converter. The cables from the motor, the 3 phases, come here, and now I put it in the frequency converter here. And now the motor is connected to the control unit. Now I will come back to the software and start the software again. So if I press the power button, now the motor will start turning. It behaves like the load, but we have now our real motor, which is the same for the turning. Now you see how the system is working, and we see the possibility of the system. Let me go back to the basics mode, and here we see the 6th step. The motor is turning step by step. So now you can imagine what we can show with the system. So we try to bring technology easy to you. That's our goal here.
So Ralph, thank you very much for this very brief and easy to understand overview. Now just let's get back that we just can make a wrap up of it. Basically, what are the advantages? And one advantage, what I clearly understood, is the modularity of that system. So what we see here is basically one example, but we can do much more with it, right?
Correctly. So we started with the converter circuits, then we go to the detectable drives, we said. So we start with a DC motor, with a 3-phase motor and a servo motor. So we go in details, we go in deep dive to understand how it works together with power electronics.
And that completely student safe, right?
Yes, it's completely student safe. So even if you do short circuits, over voltage protected, everything is done that the system is safe, and also the students are safe from the system.
What's the big unique advantage of working or teaching with that system? Why should the school, the university use that system in order to teach that topic of drive technology to their students?
So there are 2 big advantages. So on the one hand side, you can break the system down to make an easy understanding of everything. And on the other hand side, you can go up to research topics. So just take such an adapter, plug this to our interface here,
Okay.
and now you have a completely system for system which is connected to MATLAB, and you have a
So this said programming adapter here,
Yeah.
just for the audience.
and so you have a system which is running in the loop for MATLAB Simulink, and so you can do the programming. So like you do rapid prototyping in the industry. So students can learn how to operate with the system, and you have a safe system. Even if you do faults in programmation, the system will notice it and will stop.
Nothing will happen. Okay, that means I think that's a really cool advantage here, as we can say, we really can start from scratch without zero pre-knowledge and working us up to the level where it's really, where we're on the stage of research on going really deep into the whole topic.
Correct.
And this is basically like you reach the mountain of the top of the mountain basically here, and are ready then for going in the industry and for your job, as I think this is pretty much on the job market. They look for especially people who are focusing and who are able to do that here, right?
Correct.
Very, very nice. Just as a side information for MATLAB, if you want to have more information on that and how this all works together, we have an additional video for this as well, which we'll link here. Okay? So, Ralph, we are right at the end. Thank you very much for your great presentation
Thank you, Chris.
about this really cool and interesting topic. You know, if you want to have more information, just write an email, write comments to us, or just leave a comment on YouTube. And from now on, we wish you a nice day and see you soon.